Okay, so this section is on inequalities, and 1 and 2 are review, they're algebra skills. Some things to remember: when you multiply or divide by a negative number, you have to switch the inequality sign. And for number 2, these are called combined inequalities, and so this is saying that 3x plus 4 is between 1 and 16. You're including 16 but not 1. Notice how the less than signs are both pointing. They're both less than signs. The smaller number is on the left and the bigger number is on the right. And that's why we can say that this expression 3x plus 4 is between the two. So that's not an accident. You want to make sure you always have less than signs and the smaller number on the left hand side and the right. So what you should do is pause the video and see if you can do the problems, and then you can check your answers. Make sure you write your answers in interval notation. Okay, so I've done 1A. Should have gotten the interval 1 to infinity with the 1 included, and then 1B, negative infinity to negative 1/3 with the negative 1/3 included. And then 2A should have been parentheses negative 1 to 4 bracket. B, what we would do, this is a combined inequality, is we would subtract the 7 from the negative 3 and the 1/2. And get negative 10 is less than or equal to 3x, which is less than or equal to negative 6.5. And then we would divide both the sides of the inequality by 3. And the reason I'm doing this one is because I want you to hear me say that negative 6.5 over 3 is not simplified far enough. So what we have to do, this is actually a complex fraction, because negative 6.5 is negative 13 over 2, and then you're dividing that fraction by 3. So to simplify it, you just multiply by 1/3. So that's going to be negative 13/6. So you end up with x is between negative 10/3 and negative 13/6. I don't mind improper fractions as long as they're reduced, but I don't like a decimal within a fraction. So this is the final answer here. Okay, so number 3, I'm going to slow down a little bit because this is solving a quadratic inequality without a calculator, and you want to know how to do this very well. And so the first thing you want to notice is that it's quadratic. So you want to move these terms to the right here, to the left side, so that it's less than 0. So I need to subtract the 2x and subtract the 4. So step 1 is to get your quadratic, all the terms to the left. So then I'm going to subtract 4. And so that gives me x squared minus 3x minus 4 is less than 0. Okay. Next step is to factor this quadratic. Since it's an ax squared plus bx plus c form, I'm going to factor it into x minus 4, x plus 1. Okay. Now the next step is to set each of the factors equal to 0. So that's going to be x minus 4 equals 0, or x plus 1 equals 0. And so x equals 4, or x equals negative 1. Now you might have noticed it doesn't say equals 0, it says less than 0. So these are not solutions. I really didn't find the solutions. I found what I'm going to call critical points. I call them critical points because they're the x-intercepts. If I were to graph x squared minus 3x minus 4, this graph would cross the x-axis at negative 1 and 4. Not only that, that's where these values give you 0. Not only that, that's where you have a sign change. So these are critical points. And I'll explain further about what I mean by sign change by graphing the number line. So the next step is to graph your critical points, and they create regions. So like I said before, at -1 you get equals 0. Notice how you don't want it to equal 0, so I can go ahead and put a hole right here. And at 4 you get a 0. We want to know where the values are less than 0. So what we're going to do is, within these regions, I'm going to pick a test point. So from -1 to infinity, -2 is a great test point. And from -1 to 4 is 0 is a great test point. And from 4 to infinity, 5 is a test point. So I'm moving along here, and I want to find out what -2 will do when I put it in for my equation. And I always want to put it in to my factored equation right here, because that's where the math is the easiest. Okay, so if I put -2 in for x, I'm going to get -6. You can watch me do it. I'll change the color to something like light blue. If I put -2 in here for x, I get -2 minus 4, which is a -6. Now notice how I'm not going to put -6 down, I'm just going to put negative down. And then times -2 plus 1, which is a -1. And then a negative times a negative, I didn't even need to put the -1 down, just care about the signs. A negative times a negative is a positive. So what I'm saying here is that if I put -30 in for x, or put -29, 28, -2, I am going to get a negative number. A positive number when I put those values in. Okay, so this region from -1 to infinity gives me positive values. I'm going to do the same thing for my next region. I'm going to put my test point 0 in. So if I put 0 here and here for x, then I get 0 minus 4 is a negative, and 0 plus 1 is a positive, and a negative times a positive is a negative. So all the numbers between -1 and 4, and I substitute them in, I'm going to get a negative value. Then I'm going to try 5. So I'll put 5 in. 5 minus 4 is a positive, times 5 plus 1 is a positive. Positive times a positive is a positive. Notice how the signs switch. Positive, negative, positive. That happens most of the time unless you have a double root or something. So now it's time to figure out which regions represent my answer. So you may have noticed in here in blue I put highlighted less than 0. I even wrote it right here. I want all the left sides of my equation to be less than 0. I want it to be negative. So the numbers that give me negative values on the left side are the numbers between -1 and 4. So those are my solutions. So in interval notation, that would be -1 to 4. Okay, let's try 3b. Let's pick up the pace a little bit. So it's an inequality. It's a quadratic. So you have to go through and remember how to do that. That means you're gonna move all your terms to the left-hand side. So that's 4x squared minus 8x is greater than or equal to 0. And this is quadratic, but it's not in ax squared plus bx plus c form. There is no c term. So this is easy to factor. You just factor out a GCF. There's no guess and check. They both have a 4 in common. They both have an x in common. If you divide out the 4x from 4x squared, you're left with an x. If you divide -8x by 4x, you're left with -2. So these are my factors. So now, next step, set each factor equal to 0. And I'm not solving, I'm finding critical points. So my critical points are occurring at x equals 0 and x equals 2. That's where this would be 0. If I put 0 in, 4 times 0 is 0, 0 times -2 is 0. And if I put 2 in, 8 times 0 is 0. So these are my zeros, or my critical points. So I have to go an extra step, if it's an inequality, and draw a number line. And put my critical points down. At this point, if you want to notice, we are going to include solutions that equal 0 because it says greater than or equal to 0. So these are going to be part of my solution set. And then I'm going to test each of the regions. So I'm going to pick a test point in each region. And then I'm going to plug these values in. And remember what we said? The factored form is the best place to go. So if I put -1 into 4x, 4 times -1 is a negative. And -1 minus 2 is a -3. So I get a negative times a negative is a positive. Then if I try 1, I get 4 times 1 is a positive. 1 minus minus 2 is a negative, so I get a negative. If I put in 3, 4 times 3 is positive 12. 3 minus 2 is positive 1. Positive times a positive is a positive. So I know that each region has a sign associated with it. So I want this side here to be greater than or equal to 0. That means I want the left side to be positive. So I can see that the regions that are positive are the regions from 0 to negative infinity and from 2 to positive infinity. And I'm including the critical points because that's where they equal 0. So to write this in interval notation, it would be negative infinity to 0, bracket, union, bracket, 2 to infinity. This last example is not quadratic, but it's already in factored form. So that's the point. It's in factored form, and the left-hand side is less than or equal to 0. So we can use the same principles, and that is, first step is to find the critical points by setting each of the factors equal to 0. So we have critical point at -2, at 1, and at 3. And so then we can check our regions by putting in the critical points in the proper order, -2 and then 1 and then 3. And I've got these regions here. And I want to pick a test point, so I'll pick -3 in this region, 0 is this region, and 2 in this region, and 4 in that region. And those numbers in red represents all the numbers in the region. And then just like before, I'm going to put the -3 in for x in 3 places, and I don't really care about the actual values of the numbers, just the signs, because this is less than or equal to 0, and I want to find out what makes it negative. So here we go. If we put -3 in for x plus 2, I get a -1. Then if I put -3 minus 1, I get a -4. And then -3 minus 3, I get a -6. So a negative times a negative times a negative is a negative. And then if I check 0, 0 in for x gives me 0 plus 2, which is a positive number. But 0 minus 1 gives me a negative number, and 0 minus 3 gives me a negative number. So positive times a negative is a positive. If I put 2 in, 2 plus 2 is 4, that's positive. 2 minus 1 is a positive. 2 minus 3 is a negative. Positive times a positive is a negative. If I put in 4, I get a positive because 4 plus 2 is 6. And if I put in 4 minus 1, I get positive 3. And then if I put in 4 minus 3, I get positive 1. Positive times a positive times a positive is a positive. Then I'm going to look at the less than or equal to 0, and that tells me I want only negative numbers. So I look at the regions that are negative, and I want to include my zeros because it says less than or equal to 0. So that tells me I'm going to have this region over here from -2 to infinity, and the region between 1 and 3, because those are where you have your negatives. So in interval notation, that's going to be -infinity to -2, bracket, union, bracket, 1 to 3, bracket. Okay, so I want to show you how to solve this equation with the calculator. So you want to put the left-hand side in y1, so that's going to be x cubed minus 6x squared plus 9x, and then hit enter. And then in y2 you'll put the right-hand side, so second times x, close the parentheses and hit enter. And then, so we want to find out where these two intersect because we want them to equal to each other. And notice that the interval is from 1 to 6. That's good news. So because I can set up my window, I know if I go to diamond and then F2, I'm at window, I can put 1 in for x min, 6 is x max, and since it's only 5 numbers, I'm going to count by 0.5. My y min, I'll let be -10, and my y max I'll let be 10. And if you're not sure if that y is going to be good enough, you can just go to F2 for zoom and find zoom fit, which is A. And so we'll watch the left-hand function go through. There it comes. That's my cubic function. And then here comes my square root of x function. And hopefully you can see that they intersect in 2 places. You can find those intersections at this point. I'm going to show you that there's just a lot of unnecessary graph right here. So if you remember, this is y max and that's y min. This is x min and that's x max. I can go into my window and take out some of my y max. So I'm going to go to y max. It's at 54. I don't need to see that much. I'm going to take it back down to 10 and then hit graph. And that'll just help us see our intersection a little bit more. There's our cubic function, and here comes our square root function, and we're trying to solve the equation, and the place where these two functions intersect is where it is the answer. So to find this intersection, I have to go to my math menu. It's on the screen, F5. So I'll hit F5 and then pick 5 for intersection. First curve just means y1 curve, second curve means the y2 curve. Now lower bound means I'm going to hold my left arrow key down and I want to make this cursor go a little to the left of the intersection and hit enter. Upper bound means I want to go a little to the right of the intersection. Don't go all the way over here. We're only going to be able to find one intersection at a time. So we went a little to the left of this intersection, a little to the right, and we're going to hit enter. And this gives me x equals 2.17672 when x is 1.47537. That's not your answer. The x value is your answer. Okay, so one of the x values is 2.18 if we rounded. Then we need to find this solution. So we're going to do F5 and 5 for intersection. And I'm going to go ahead and move over to the intersection area. It says first curve. So I'm on my y1 curve, now I'm on my y2 curve, and I want to go a little to the left and a little to the right. And so my second intersection is 3.72. Okay, so we have x equals 2.18 or x equals 3.72. Now remember, you don't use the y coordinate at all. We're only finding the values of x that cause the y values to equal. So we don't ignore the y values. These are the x values that make this left side and this right side equal. So that's it. Okay, so our last one is a word problem, and this is test level. You'll have a word problem to do. It says an appliance manufacturer estimates that the profit Y in dollars generated by producing X cooktops per month is given by that function. So I'm going to write down what X is and what Y is. It's a good habit. Number of cooktops produced per month is what X is. And Y is profit, and I want to make sure I don't forget to notice if it's in thousands, and it's not in thousands. So I know what X and Y are, and I know that this function y equals 10x plus 0.5x squared minus 0.001x cubed minus 5,000 is the profit function. And notice that it's giving us an interval just like the last one. That's great news. That's going to help us use zoom fit. This will be my x min. That'll be my x max. And we'll be able to use zoom fit because they gave us some x values. Now it says for what range of values of x is the company's profit greater than 15,000. So this is why I wrote down this. Y is my profit. So we want to know when the function is greater than 15,000. So we want to know when 10x plus 0.5x squared minus 0.001x cubed minus 5,000. We want to know when this profit is greater than 15,000. So just like before, we're going to use the calculator. We're going to put y1, this left-hand side in y1, and the right-hand side in y2. The difference now is that we want a range of values. We want to know when the profit is greater than 15,000. Okay. So what we want to do is go to the y equals and put the left-hand side in, which I've already done, and the right side in. And then if you go to the window, remember you were given an interval, and that's great news. You were given the interval from 0 to 450. So we put in 0 for x min and x max 450. X scale, I like to divide by 10, so I'll count by 45s. Don't worry about the y min and y max. We can just hit zoom, which is the F2 button, and then zoom fit. And watch this graph here. Okay, so here comes our longer function, and then it should come up with a straight line right there. That's your 15,000. And so what we want to remember is that we want to know when the profit is greater than 15,000. So above this line, 15,000, it's more than 15,000, and below the line, it's less than 15,000. So what we want to do is find these intersection points, and we want to know we know that the answer is above that. So the answer is going to be between this and this. Okay, so this is another intersection problem. So we'll do F5 intersection, enter, enter, and then we want to be a little to the left and a little to the right. And the first intersection is 279.13. And then we'll hit F5 again, and enter, enter, and then we want to go to the area of the second intersection, left bound, hit enter, go a little to the right, hit enter, and we have a second intersection of 400. Okay, so the answer to the number of cooktops that need to be produced to make a profit, a weekly profit of more than 15,000, tells me that I do not want to include the 279. So mathematically, it'd be 279.13 to 400 cooktops. If you really want to do a good job of interpreting, then you want to know that you can't have 0.13 of a cooktop, and it can't be 279 because that would be below the 15,000 profit mark. So really, you would want to produce between 280 and 400 cooktops to get your profit greater than $15,000.